Here's a review of some of the problems we worked on in class in Chapter 9, the closure problems. In 9.120, you were asked to write an inequality that was represented on the graph. If you use the slope-intercept form, you can see the slope is 1/2 because it goes up 2 and over 4. So rise over run is 1/2, and the y-intercept's at -2. So you can write 1/2 x minus 2. Then you still need to determine what type of inequality should be used. Here it's shaded above, so if we use 0, 0 as a test point, 0 would be greater than 0 minus 2, so it's going to be y is greater than, not equal to though, because it's a dotted line, 1/2 x minus 2. In problem 9.124, you could let x stand for boys and y stand for the number of girls. You know that all together 45 people went, so when you combine them, x plus y is equal to 45. But unfortunately, the boys had to pay $5, the girls only had to pay $3. So when you combine those up, the total money is $175. You could solve this using a system. Here's our system of equations. If you wanted to use elimination, you could by making this a 5 and subtracting these, but this would also have to be a 5, and so would this. Another way to do this is using substitution. If you take away x from both sides, you'll have y is equal to 45 minus x. You can then substitute that right in for here in this y. Then you would have an equation right here to solve for x. You'll get x is 20, which means there were 20 boys that attended the dance. And then since there were 45 people altogether, there were 25 girls. Finally, in this problem, you were asked to write and solve an inequality to determine the possible ages Audrey could be. If you tripled her age and added 9, you still wouldn't be as old as 60. So we're not going to write equal to 60, we'll just write less than 60. When you solve for x, you'll get x is less than 17. So Audrey could be any ages less than 17.